Welcome back. Open your books to page 369. We are starting a new activity today. So we're in activity 25. Lesson 25.1 is all about multiplying binomials. So we are going to use a graphic organizer in order to multiply expressions. And then we're also going to use something called the distributive property in order to multiply expressions. And I am going to teach you an acronym called FOIL. So we have a computer company, Tricom Computers, and they set up local area networks in offices. And when they do that, they set up computers and printers in a square or a rectangle. So printers are placed in each corner of the room. The primary printer A serves a certain number of computers, and so does B, C, and D. So for question A, if each dot represents a computer, how many computers in this room will be assigned to each of the printers? So go ahead and count them up and write down your answers. How many computers? Printer A has 25 computers. B has 10 computers. Printer C also has 10 computers. And printer D has 4. Go ahead and answer question 2. What is the total number of computers in the room? So the total that I got was 49. And let's do one way we can do that. So 25 plus 10 plus 10 plus 4 gives us 49. What's another way we could do this though? Let's go back up and look. If I count, there's 7 computers here, 7 computers here, and let's multiply side times side, or length times width. So if we multiply 7 times 7, we get 49. So that's a second way we can do this. So question 3, we have another example of an office. And if we look, it's like 5 by 5, and then there's 4 and 4. A technician claimed that since 9 equals 5 plus 4, so 5 plus 4 would be 9, the number of computers in the office could be written as an expression using only the numbers 5 and 4. Is the technician correct? Yes. So instead of using 9, we could just use the 5 plus 4 for one side of the room, and we can multiply that by 5 plus 4, which is the other side of the room. Well, what's another way to come up with the total number of computers is to count each of the 4 boxes. So this first box would be 5 times 5, which is 25. The next box is a 5 by 4. The other box is a 4 by 5. And the last box is a 4 by 4, which is 16. And if we add these all together, we get our total to be, so add these up, the total here is 81. Now, remember the technician above said that the side was 9, and 9 times 9 is 81. All right, I'm going to skip questions 5 and 6 and jump for now and jump to question 7. The office to the right here has A squared computers. Fill in the number of computers in each section if it is split into a 5 plus 3 squared configuration. So in each box, what we're going to do is we're going to multiply the side times side. So 5 times 5 is 25. 5 times 3 is 15. 3 times 5 is 15. And then 3 times 3, this side is 3 and this side is 3. So in our last box, we get 9. So go ahead and pause the video, and I want you to answer question 8. The total number of computers is 64. 2 ways to get the total. Well, they told us 8 squared. 8 squared is 8 times 8, which was this total side multiplied by that total side, which gives us 64. Another way to do it is to think about 5 times 3 squared, or 5 plus 3, multiplied by 5 plus 3, which equals this 25 plus 15 plus 15 plus 9, which gives us 64. For question 9, it says each possible office configuration below, we're going to draw a diagram like what we just did in questions 7 and 8. Label the number of computers on the edge of each section and determine the total number of computers in the room by adding all of the numbers together in each section. Okay, so this needs to be a 2 by 2. So we're going to have 4 boxes here. And on each edge, we're going to label it with a 2 plus 3, 2 plus 3. So here's how we do this. Edge times edge. 2 times 2 is 4. 2 times 3 is 6. 2 times 3 is 6. And then lastly, we get a 3 times 3, which is 9. Then it says go ahead and add the number of computers up in each section. So if I write that out, just to show you once, it's 4 plus 6 plus 6 plus 9. Get your total. So the total here would be 25 computers. So I want you to take the time, to pause the video and try questions B and C on your own and see if you can come up with the total. Okay, letter B. 4 times 4 is 16. 4 times 1 is 4. 4 times 1 is 4. 1 times 1 is 1. Add them all up. 16 plus 4 plus 4 plus 1. We get 25 computers again. Letter C. 3 times 3 is 9. 3 times 7 is 21. 3 times 7 is 21. 7 times 7 is 49. Take all 4 of these inside numbers, add them up. We get 100 computers. So we are going to pause from the book really quickly and go through these notes. Or why don't I come back to these notes? No, let's do these notes. Let's do these notes. Okay, sorry. The first method is called the box method. So you can type this in using Kami, or you can do this on a separate piece of paper. This type of method works for every single multiplication problem. Okay, and we just saw a binomial times a binomial. We had a 2 by 2. And so what we're going to do is we are going to draw a box, and we have to have a section for each term. So if I have a binomial, that means I need to have a 2 by 2. 3x would go here, -5. So there's 2 terms, so they need their own boxes. And then 5x in a +2. Now, it doesn't matter if you put this binomial on the top or on the side. Okay? So 3x minus 5 could have been on the side, and 5x +2 could have been on the top. It doesn't matter, but just make sure the 3x and the -5 are together, and the 5x and 2 are together. Okay, and now we're going to multiply. Okay, multiply each term together, and then we're going to write the answer or the product inside the box. So 3x times 5x. Well, 3 times 5 is 15. And then remember our exponent rules. We have a 1 times 1. And when we're multiplying, we add them, and 1 plus 1 is 2. Then 5x times -5 is -25x. 3x times 2 is 6x. 2 times -5 is -10. All right, now what we're going to do is combined like terms. Okay, combined like terms. So if I'm looking on my diagonal, I see a -25x and a 6x. These are considered like terms because they both have x's. So what we need to do is we're going to add these up, just like we learned in activity 24. So I'm going to leave the 15x squared alone because there's nothing to combine it with. But then think, what is 6 minus 25x? Or -25x plus 6? We get -19x. And then lastly, I have -10 at the end. That's my constant term, and there's nothing to combine it with. So when I multiplied here, I had a binomial times a binomial, but my answer ended up being a trinomial with 3 terms. All right, also in your notes, let's do 2 more examples, and then we'll head back into our book. So we're going to multiply these using the box method. Okay? So remember, it doesn't matter. T minus 10, I'm going to write it here, but I could have also written that on the top. Doesn't matter. T with a positive 6 is going to go there. Okay. This kind of reminds me of Punnett squares from science class. So we're multiplying t times t, and my answer is going to go in this first box. Remember our exponent rules. 1 plus 1 is 2. Then we're going to multiply t times 6, and it's going to go in this box, which is 6t. The number goes first. That's our coefficient. Then we're going to multiply the negative 10 with the t. Negative 10 times t, which is negative 10t. And then lastly, what we're going to multiply is negative 10 times 6, and it goes in this box. Negative 10 times 6 is negative 60. And then if I'm looking, these right here are my like terms. So when I add all of these up, there's nothing I can combine t squared with. But then negative 10t plus 6t is negative 4t. And then minus 60 comes at the end. And we're left with a trinomial, t squared minus 4t minus 60. So why don't you try the next question? Pause the video, take the time to set it up, and come up with your answer. If you switched your 7p minus 2 and 3p minus 4, that's okay. I chose to write it this way this time, but we're still going to come up with the same answer if we did this correctly. 3 times 7 and p times p. 3p times negative 2 is negative 6p. 7p times negative 4 is negative 28p. Negative 4 times negative 2, 2 negatives make a positive 8. Now we're going to add them all up. These are the only 2 like terms, so we're going to leave the 21. Negative 28 minus 6 would be negative 34p, and then positive 8 comes at the end, and this is my final answer. And this looks different than the computers in the book because those were all constant terms, those were all numbers, so we just added them all together and got one final number. Okay, so back in the book, let's take a look at question 10. This is on page 372. The computer company has a minimum requirement of 25 computers per installation, and it's arranged in a 5 by 5. So here's my 5, there's my other 5. Some rooms can be larger than others and can accommodate more than 5 computers along each wall. So we're going to use this box and this variable expression to represent the total number of computers needed for any office having X more than 5 computers along each wall. So these boxes are a little different looking than before because I made all my boxes the same size. But go ahead and try to fill in these boxes. So multiply your side times side. Five times 5 is 25. 5 times x. 5 times x. x times x is x squared. So we are going to skip question 10 and jump straight to question 11. So we're going to write an expression for the sum of the number of computers. So let's go ahead and add all 4 of these boxes up, and let's write our answer in standard form. So first I see an x squared. And on my diagonals, I have 5x plus 5x, which gives us 10x. And lastly, my constant term is the 25. We are going to skip question 12 for now, and we're going to come back to this when I teach you an easier way to do this. And we're going to go to question 13 on the top of page 373. The graphic organizer, also called the box method, below can be used to arrange multiplications of the distributive property. So if we're looking at this, it doesn't have to be related to the number of computers in an office. So for example, if I have 5 times 7, here's my 5 and here's my 7, they're breaking it up into 3 plus 2 and 4 plus 3. And then when we multiply the sides, we get what's in the inside. Okay, so 3 times 4 is 12, 4 times 2 is 8, 3 times 3 is 9, and 2 times 3 is 6. Let's go ahead and find out the total number here. So add them all up. And we get 35. So let's draw, again, a graphic organizer, or the box. And I know it's going to be a 2 by 2 because this is a binomial times a binomial. Go ahead and multiply, label each square in the middle, and then find your sum. Ten, 15, 4, and 6. Add them all up. We get a total of 35. Okay, go ahead and pause and do question 14. Six times 4 is 24, negative 12, negative 12, positive 6. And add these all up. We get a total of 6. Now, question 15 wants us to use the distributive property, which we haven't learned yet. And this is the second method that we're going to end up putting on our note sheet. But what we're going to do is we're going to take this 6 and distribute it to the 4 and to the negative 2. So what this would look like is 6 times 4 what do we get? Six times negative 2. Oops. 6 times negative 2 is negative 12. So there's our first two numbers. 24 minus 12 is 12. Okay. Then what we'd also need to do is take this negative 3 and distribute it to the 4 and the 2. So negative 3 times 4 is 12. Negative 3 times negative 2 is 6. Negative 12 plus 6 is negative 6. Then we got to combine these together. 12 minus 6 equals 6. And that seems a little confusing. Okay? But I promise it's going to get easier. It's going to get better. So use this graphic organizer to multiply. Then we're going to get our answer here. Positive 6, emphasis on the positive there, because negative times negative is a positive. So now let's find the sum. So x squared, these are like terms. Negative 3 subtract 2 is negative 5x, and positive 6. So that would be our final answer there. Okay, and let's do the distributive property again, and then we'll get into how to do this more on our note sheet and an easier way in the future, okay? So what we're going to do, remember we have to distribute, so we're going to take this x, and we need to multiply it by both of these. So it would be x times x minus 3. So x times x is x squared. X times negative 3 is negative 3x. And I'm going to make a second line because I'm kind of running out of room here. Negative 2, bear with me, this is going to get easier, I promise. Negative 2 times the second set of parentheses. So we get negative 2x and a positive 6. Oh, wait a second here. Something's the same. These four terms are identical to our four terms here. Okay, these were our like terms, and I have the same like terms right here. So essentially, the distributive property and the box method are the same because when I combine these, we get the exact same answer here. So in the future, going forward, you have a choice whether to use the box method or the distributive property. So next video, we'll add distributive property to our notes. It'll get easier. Then I'll teach you FOIL, and it'll seem even easier to you. But if you still prefer, you can also use the box method instead.